Hey y'all, so in 3.6 we start solving logarithmic equations. So there's a lot new here. We're covering a couple different types of equations. So what I want to do is put together this video in case you missed class or you just need a recap. Basically, I'm going to go through the async problems, and I'm going to do the first 5 for you. So I'll do 1 through 5, and then you'll have 6 through 10 to do, which will kind of mirror the first 5. So it'll be really similar to the ones I'm doing, so you'll have some examples to look back at. And then there's a challenge problem, and this is a challenge because it's a little more difficult than the ones before it, but you have all the skills you need to do that problem. You will have to call back to some old skills we haven't used in a few weeks, but you should be able to do it, so try it out. Okay, so I'm going to do some math. Alright, so our first problem here, we've got 6 to the xth power equals 25. So basically the biggest skill we've learned so far, and I've been like pounding you to death with this, is the ability to translate a log into an exponential, right? Using our friend Ben the Bunny, or we can do the roll the log trick. It's going to allow us to translate our expressions. So I'm looking at this. I got 6 to the x power equals 25. So I'm going to think, I know what the answer is going to be, like 1 to 2, somewhere in there, because I know 6 to the first power is 6, 6 squared is 36, so 25 is somewhere between the first power and the second power. So I'm thinking like 1.5, maybe a little bit less. We'll see. All right. So the first thing I want to do is translate this into a logarithm. A logarithm is going to allow me to answer the question of what is that exponent. So we can use Ben the Bunny or roll the log here. We get log with a base of 6 of 25 is equal to x. All right, this is about as far as I can go. This is a 6, not a b. About as far as I can go. So I'm going to go ahead and grab a calculator, and that's going to help me answer this question. So again, Desmos is a good option for log calculating. So I got log base 6 of 25, and there's my answer, 1.796. Okay, so x is about 1.796. We're rounding off a little bit. That's why I'm using the squiggly boys here, right? Because it's about that, but not exactly. All right, sweet. So let's take a look at number 2 here. Let me move you. All right. So on number 2, we've got log base 3 of x minus 5 equals 2. So here's our first like legitimate logarithmic equation that we need to solve. So we got log with a base of 3. There's a whole algebra expression inside the log, and then it's equal to 2. So again, all we need to know is Ben the Bunny, right? He's always watching. He's always here. Ben the Bunny. All right. So I'm going to roll my log here, or you can use Ben to help you translate. So this is saying the same thing as 3 to the second power is equal to x minus 5. All right, again, simple translation, right? Knowing that pattern, using Benny there, is going to help us get to an equation that's not so scary. 3 squared, 3 times 3 is 9. So 9 is equal to some number minus 5. So 9 must be 14. All right, so once we get that translation step out of the way, we're off to some pretty simple algebra. All right, just gonna erase this. I am going kind of quick through this, y'all, but you can always rewind the video, but I don't want to give you too long of a video to watch here. All right, sweet. All right, number 3 here. This time we have 2 logs in our equation. So log 45x minus log of 3 is equal to 1. So to answer this question, we need to make use of those log properties that you practice in the last async activity. So we had these properties that said that if I am adding or subtracting 2 logs, as long as those logs have the same base, we can actually squish them together, right? We can condense the logs using the product rule and the quotient rule. Here, since we have subtraction, we want the quotient rule. So that tells us we can take 2 logs and put them together. Again, this is what our last assignment was all about. And notice that inside the log, I have these two arguments, and we're dividing them. All right, that's how our quotient rule works. Okay, so now I have a single log, and once again, we want to make use of Ben the bunny, right? It's always there, he's always watching to get us to that last bit. So before I do that, 45x over 3, 45 divides by 3. So I can simplify this. I'm going to go ahead and do that. This is the same thing as saying log of 15x. And again, 45 divided by 3 is 15. So this is just a little cleaner. All right, now I'm going to translate. So we started our base. Remember, this is a common log. We don't see a base, which means our base is, by default, 10. All right, so 10 to the first power is equal to 15x. Cool. So the first power, not really doing anything for us. 10 to the first power is just 10, so I'm going to get rid of that. And that's equal to 15 x's, but we just want one x, so I'll divide by 15 to get it alone, and we get x is equal to 10 over 15. That is the correct answer. It's not the best answer. We should always simplify or reduce our fractions. So 10 over 5 is the same thing as 2/3. Again, to reduce this, I noticed both of those numbers are multiples of 5s, so I divide by 5 over 5. I'm dividing by 1, so I have essentially the same number, just a different form, which is simple. All right, so again, using the log properties, we can combine the logs, and then once again, we use Ben the bunny to translate. All right, next one here, we got number 4. Okay, this time we have exponentials. We have two different exponentials on both sides of the equation here. All right, so I got 3 to the 2x plus 4 power equals 3 to the x plus 3 power. So again, this is really intimidating because we've got exponents on both sides and all this junk going on. But we have the same base on both sides. So essentially this is saying 3 to some power is equal to 3 to some power. So those two powers must be the same thing. So we can actually just get rid of those bases. If those powers must be equal, then these two expressions must be equal. So now we just have something that should be pretty solvable, right? Get our x's on one side, the numbers on the other. So I'm going to get all my x's over here on the left. In the same step, I'm going to go ahead and subtract 4 from both sides to get my numbers over on the right, and there's our answer. X is equal to -1. Sweet. So again, we had up here, we had exponents on both sides of the equation, but we happen to have the same base. 3 to some power equals 3 to some power. So we were able to just get rid of those bases and set the exponents equal. All right, on number 5, we don't have the same base. It won't let me shrink this. I'm just going to hide it. Get out of here. All right, last one here. 2 to the 4x equals 8 to the x plus 2. Okay, so we can't do that thing where we just cross out the base because our bases aren't the same. 2 to some power is not the same thing as 8 to some power. Except 8 is a power of 2. Right? We think about our powers of 2, which you probably know pretty well, whether you know it or not, because of technology, computers and whatnot. 2 to the third power is 8. So this fact right here is really important to solving this problem. If I know 2 to the third power is 8, maybe we can make these two bases match. On the left I have a base of 2. If I could take this 8 and turn it into base 2, then we should be able to solve this really easily like we did on number 4. Okay, so I'm going to go in here, I'm going to replace 8 with 2 to the third power. We do a quick little substitution. Oh. So instead of having 8 to the x plus 2, now I have 2 cubed to the x plus 2. We haven't changed anything. 8 is 2 to the third. Right, we know that. We can prove that. So that's a legal substitution. We haven't done anything wrong here. All right, now we have a power raised to a power. Remember learning all those exponent properties, reviewing all that? Well, this is why. When we have a power to a power, we multiply those powers together. So we have 3 times x plus 2. It's really important you remember that it's 3 times this whole expression. So we're going to distribute that 3. Oh, that's not 3, that's 2. 3x plus 6. All right, now let me zoom in here a little bit. Now, just like we had before, we have base 2 on both sides, so we can cancel our bases. We got 4x equals 3x plus 6. Subtract our 3x here, we get x. X equals 6. All right, so again, we didn't have the same base here, but we were actually clever enough to make the bases match, because we noticed that although this 8 is not the same thing as 2, it is a power of 2, so we're able to force it to match. We're not going to talk about what if you can't do that, like what if this was a 7, right? We'll talk about that next class if we have time. Things get a little more complicated, but you can kind of see how it would be solved if you think about what's really happening here. Although this works, and this is fine for all but the most formal proof, we can't just cancel out the bases. It's not really what's happening. Realistically, when we have something like this, the way in which we are getting rid of the base is by performing a log to both sides. All right, we can take a log base of 2 of both sides, performing the same operation on left and right, so we're maintaining equality. And then log base 2 of 2 is just 1. 2 to what power gives me 2? Well, 2 does. So we can actually do this in a really formal way. And again, for my class, we're not worried about all these formalities. If you ever work up to like an AP test or something like that, these things become more important. Or if you want to do formal proofs, it's more important to show these steps. But for now, just crossing out your base is fine. But I do want to show you what's happening sort of under the hood here. And again, like I said, log base 2 of 2 is just 1, right? 2 to what power gives me 2? 2 to the first power gives me 2. So I've got 4x times 1 is just 4x. 3x plus 2 times 1 is just, or it's just 3x plus 6, not 2, sorry. Cool, so we get to the same place, but this is a lot more formal and just kind of clunky. So I like to teach it this way because you get the same sense, but this is sort of what's happening under the hood over here. And if you can see that, then you'll be able to figure out, well, how do we solve when we can't do these tricks? We could take a log base 2 of 7, right? And so we'd have essentially the same thing, but just be dealing with something that's, sorry, not 7. I'm getting off track. I gotta stop. I don't want to make a video too long. If you have questions after this, if you're trying to work through those last 5 problems and you're still struggling or you get stuck or you just want to check your answer, shoot me an email or shoot me a remind text, and I'd be happy to help you. Thanks. Good luck. Do the challenge problem.